Good morning, all. Today I'll be talking about elastomeric impression materials. So we have the settings, that is definition, history, classification, ideal requirements, properties, disinfection, conclusion, references. So as you all know, you won't get a second chance to make a primary impression. So impression is one of the most important thing when you come to the application of a denture or an FPD or a crown. So according to Divan, he says, an impression is a record, a facsimile of mouth tissue taken in an unstrained rest position or in various position of displacement. And we can say an impression is a negative replica of your oral cavity. So we have different impression materials we use to make the primary impression, both as well as secondary impression. So elastomer, a type of a polymer that has glass transition temperature that is below its surface temperature. These materials are characterized by low stiffness and extremely large elastic strain. So normally we use elastomeric impression material for making a secondary or a master impression. So elastomeric impression materials, it's a group of flexible chemical polymers that are either chemically or physically cross-linked. Generally, they can be easily stretched and rapidly recover the original dimension when applied stresses are released. So let's move on to the history. The requirement for a stable and accurate and elastic material led to introduction of this elastomeric impressions into dentistry. The polysulfide rubber was the first elastomeric impression introduced for industrial application in 1929. The liquid polymers were developed in 1943. After the Second World War, they were introduced into industry in the 1950s. And there is only one brand that of the polyether material is commercially available that was introduced in Germany in late 1960s. In 1970s, additional silicone was introduced as a dental impression material. In 1988, the latest addition in light cure elastomer was introduced. In 1990 to 2000, new auto device and delivery system for manipulation of this elastomeric impression materials were introduced. So let's see what are the ideal requirements of an impression material. So it should sufficiently fluid to adapt the oral tissue, should be viscous enough to be contained in a tray and able to transform into a rubbery or rigid solid in mouth in a reasonable time, and it should resist distortion or tearing when we are removing the impression from the mouth, and it should be dimensionally stable long enough to allow to pour one or more cast, and impression should maintain the dimensional stability after removal of the cast so that the second or third cast can be made, and it should be biocompatible and cost effective in terms of time as well as the expense of the associated processing equipments. Now let's move into the classification of elastomeric impression material. We have polysulfide, polyether, addition, silicone, and condensation silicone. So according to ADA specification, there is another classification, that is type 1, type 2, type 3. This is based on the maximum compression set and maximum percentage of flow. So the properties reflect the elastic recovery of the material after a compressive strain or a set, and B, resistance to distortion under a small compressive stress, and C, total linear dimensional change of a specimen after a minimum of 24 hours in unstrained condition. Let's move to the properties. So it has worked. It should be workable, should be dimensionally stable, should be accurate, and rheological property, elasticity, tear strength, biocompatibility, and shelf life. So let's go in detail. What is the working time? What do you mean by working time? What is the difference between working time and setting time? Let's see what is working time. Working time is nothing but from the start of the mix till the consistency no longer acceptable for product's intended purpose. Okay, setting time is the beginning of the mixing until the material hardens. So working time, you have only from start of the mix till consistency long and acceptable for intended purpose. For setting time, it elapses till the material hardens. And you have temperature, viscosity, humidity has an influence in the this working time and setting time. Let's see mean working time and mean setting time of different impression materials. So we have polysulfate, condensation silicon, addition silicon, polyether. So mean working time on 23 degrees Celsius and uh, 37 degrees Celsius. Mean setting time in minutes in 23 degrees Celsius and under 37 degrees Celsius. So if you compare all the impression elastomeric impression material, mean working time is less for addition silicon at low temperature at 23 and 37. It is 3.1 and 1.8. When coming to mean setting time, addition silicon is the mean setting at of 8.9 and 5.9 respectively in 23 degrees Celsius and 37. And you can see polysulfase, the uh, setting time of 16 and 12.5 respectively, which is comparatively greater than the other elastomeric impression material. So increase in temperature, it increase in the curing rate, and it will also decrease the working and setting time. So you can see setting time and working time decrease when temperature increase from 23 to 37. And also viscosity, when viscosity increases, there is a decrease in working and setting time. And we can also alter the base and catalyst ratios, but it may result in unpredictable changes in the polymerization reaction. So let's move to dimensional stability. So compare addition silicon, polyether, polysulfate, and condensed silicon. In this graph, XY graph, we can see linear contraction was time. So um, addition silicon, it's mostly constant. It's 0.2 to in between zero point 0.2 and 0.3 percentage even after 24 hours. Polyether, it's a slight increase from zero point 0.2 about to 0.3. Then it stays constant. When come to polysulfate, there is a slow increase of linear contraction from zero point 0.2 till 0.5. But in case of condensation silicon, you can see a rapid increase in linear contraction between 0 to 6 hours. Then there is a slow increase till it reaches zero point 0.7, in between zero point 0.7 and zero point 0.8. So polysulfate and condensation silicon cast should be poured immediately, and polyether, since it is maintained its yes, there is only minimal shrinkage even after 24 hours. It can be delayed up to 24 hours to 1 week. And hydrogen gas is released after setting from early generation of polyoxyphalosis line. And so to avoid bubbles, we have to delay the pouring of cast. Moving to rheological properties, ideally it should flow freely and wet the tissue as it being injected to achieve adaptation, then resist flow away from the indented surface areas. Polysulfate, there's lowest viscosity, flexibility allows easy removal from the undercuts. In case of addition silicon polyether, they are pseudoplastic material. What do you mean by pseudoplasticity? Nothing but there is a decrease in viscosity, that means increase in flow with increase in strain. So let's see what is what about elasticity? An impression material sustains some deformation as it removed from the mouth, but must rebound it to pre-removal dimensions. So impression with the sufficiently high elastic limit should not sustain permanent deformation. And the elastic properties of the ceramostomach impression materials improve with an increase in curing in the mouth. An extra time of 1 or 2 minutes before removal may be beneficial. So, relative amount of permanent deformation in compression following strain induced during removal. So, we can it's marked as an increasing order. So, permanent deformation, addition silicon is greater than condensation silicon, it's greater than polyether, it's greater than polysulfate. So recovery of elastic deformation following strain is less rapid for polysulfate than other three. So ideal silicon is the most ideally elastic material among the elastomeric materials. Coming to stiffness, so when you compare all the impression materials, polysulfate got higher stiffness than condensation silicon, addition silicon, and polyether. So the original polyether material is 27 times stiffer than light bodies polysulfate impression materials. So let's come to tear strength. So tear strength is nothing but resistance to fracture of an elastic material subject to tensile force acting perpendicular to surface flow, or the amount of force needed to tear a specified specimen divided by the thickness of specimen is called tear strength. So this is very important when we try to remove the impression material in interproximal or subgingival areas. So the gingival areas of an impression materials are very thin often. So there's a chance of tear of materials. So if it doesn't have an adequate tear strength. So the ranking of tear strength is given from lowest to highest. Hydrocolloids got lowest tear strength. Silicons, then polyether and polysulfate got high tear strength. Let's move to biocompatibility. So among the four, polysulfate is most biocompatible, and polyether is highest cytotoxic, and most likely this biocompatibility problem occurs when a segment of impression material is lodged in gingival sulcus. As I said earlier, uh, there is a chance of tearing of impression material in subgingival areas, interproximal areas. So this can lead to biocompatible issues is left behind. It can cause gingival inflammation. In evidence of tearing, we should examine carefully. We should remove any remnants of the impression material. So, and radio opacities of polysulfate is advantageous in these situations. If needed, we can make radiograph and we can verify our findings whether any remnants of impression materials is present or not. Shelf lives. You always should know about the life of an impression material so that to avoid technical difficulty while using it. Uh, Less deterioration when we store material in dry or cold environment in a container. And if you're using tubes, it should be kept tightly closed. And impression material should not be used more than 6 months. And Sir by Donovan in 2004. So he says maximum time we can use an impression material after start of uses six months. And let's coming to disinfection of impression materials. So what is disinfection? Destruction of all infective organisms from a surface is known as disinfection. So 27% glutaraldehyde can be used in case of most elastomers. And how to do this disinfection? Wrap the impression in a disinfectant soft paper towel, place in a sealed bag for 10 minutes. And we have different materials for using disinfection uh, based on each type of impression material. In case of alginate, agar, polysulfate, and polyether, and other impression materials, zinc oxide eugenol, and impression compound. Uh, let's see, for in case of polysulfide and silicons, the method is immersion. We can use glutaraldehyde, chlorine compounds, iodophores, or phenolics, and disinfectants requiring more than 30-minute exposure is not required. So maximum exposure we should limit to 30 minutes. In case of polyether, chlorine compounds or iodophores can be used, and in case of other impression materials like ZOE, we use glutaraldehyde or iodophores, and impression compounds, iodophores or chlorine compounds can be used. So coming to conclusion, the ability to record consistently good impression is both science and an art. Impression technique, methods, and materials are evolving and changing, but underlying principles and fundamentals remains constant. So an ideal impression must be in the mind of dentist before it can be in exam. There is a knowledge and experience that enables a dentist to create desirable results. Thank you.